let's see what real valued function is. Okay, the real valued function, before going ahead, there are two models of questions that are asked in this. Before going to the concept of this, there are two models of questions that are asked. First model is find the domain, find the range of a real valued function f of x is equal to 1 by 6x minus x square minus 5, something like that. So they'll give you a function and they'll ask you to find domain and range. So this is one kind of model. This is model 2, second model. The questions that may ask is, they'll give you f, both the functions like this. Now from this they will ask a bunch of different types of questions. They might ask find the value of f plus g, or f minus g, or f plus 4, or f into g, okay, or f by g. These are the different types of questions that may ask. These are two models of questions in real valued functions. Let us see previous questions. This is from the last 4 years. This is a long type question. If you see here, there is a question here, f and g. They're asking to find f plus g and f g. So this is 7 marks question. Okay. And what about 2 marks questions? In 2 marks questions, if you see, they'll ask straight away find the domain of the real valued function f of x. And there's also one more question, find the domain of the real valued function f of x is equal to an expression. Find the range of the real valued function. So this is asked in 2015. This question is 2015. This is 2016, and the very first one is 2018. These are some of the previous questions asked. Now let's go into the concept or the definition. Before going to definition, more than the definition, it is important to understand the meaning of real valued function. I'll simply write it in a statement. If range of a function is a subset of R is a real number, then such a function is called real valued function. If the range of a function is subset of real numbers, then such a function is called real valued function. Okay, what does that mean is, if f is a function and f of x, what does it become? It's a range. If f of x belongs to R, okay, the range of the function is subset of real numbers, then such a function is called real valued function. Okay, it's very, very simple. Now, as we have seen, in order to there are two models of problems here, right? Model 1 is finding the domain, range. Okay, for that there are certain rules to follow. So here is the first rule. Okay, to find the domain of a function, you have to make sure that it is not undefined, or in case of a fraction, the denominator should not become 0. To find the domain of function, you have to make sure it is not undefined, and in case of a fraction, there is no 0 in the denominator. And the second one is, there is no negative numbers under the square root. There are no negative numbers under the square root. Okay, let's take an example and you will understand it better. The question is, find the domain of a real valued function f such that f of x is equal to 1 by 6x minus x square minus 5. Now we know that if f is a real valued function, then f of x belongs to R. So what is f of x? 1 by 6x minus x square minus 5. It should belong to R, right? When does this belong to R? When it is defined. That is, for example, if the denominator, take this one, if the denominator becomes 0, it becomes undefined, and this f of x does not belongs to R. So therefore, this should not be equal to 0. 6x minus x square minus 5 should not be equal to 0. Now multiplying with minus 1 on both sides, it becomes x square minus 6x plus 5 not equal to 0. And then you can write minus 6x as minus 5x and minus x. Then it becomes, and take x common, x times x minus 5, and take minus 1 common, x minus 5 not equal to 0. Now it becomes x minus 1 into x minus 5 not equal to 0, which implies x is not equal to 1 and x is not equal to 5. What does that mean? If you put x is equal to 1, it becomes 6 minus 1 minus 5, that is 6 minus 6, 1 by 0, it becomes undefined. For x is equal to 1, this entire fraction becomes undefined. Similarly, for x is equal to 5, this entire fraction becomes undefined. So for all the real numbers except 1 and 5, this fraction is defined. That is what we have written here. Similarly, for example, without solving another problem, just taking down the situation, if problem is given as something like this, root of x square minus a square, f of x, where f is a real number, is root of x square minus a square. Now here, take the second rule, no negative numbers under square root. So it should always be positive. It also can be 0. Therefore, x square minus a square is greater than or equal to 0, and solve it in a similar fashion. We'll see the problems in detail later. Let's say, for example, if the same question is in this form. Okay, then here, this is under the root, so you can simply write x square minus a square greater than or equal to 0. But here it is a fraction, and if it becomes 0, if it is equal to 0, this becomes undefined. So you write it as x square minus a square greater than 0, but not x square minus a square greater than or equal to 0. Alright, this is the first rule. Now second rule is solving inequality. So as you have seen earlier in the example, you'll be solving a bunch of inequalities. Okay, let's say, for example, x or 9 minus x is greater than 0. Okay, then if you multiply with minus 1 on both sides, it becomes x minus 9. Okay, it changes the sign, less than 0. What I'm trying to tell you is, whenever you multiply with minus 1, it changes sign. For example, 3 minus 4x square is less than 0. If you write 4x square minus 3, you have to make it greater than 0. If 3x minus 4x square is less than 0, to make it 4x square minus 3 greater than 0. This is the first rule. Second one is, if 1 by x is greater than 0, okay, or 1 by x is greater than 6, let's say, you cannot write something like this. You have to make sure that you are cross multiplying a perfect square or an even power. That implies you multiply and divide with x on both sides. Now send it to that side. Now x minus 6x square is greater than 0. Then here again 6x square minus x is less than 0. Okay, always cross multiply a positive number. For that you have to make it positive, okay, and then multiply. Another example of similar to this is, if let's say x plus 3 by x plus 4, x plus 3 by x plus 5 is less than 7. Okay, Now you cannot directly cross multiply here. What you have to do is x minus 5 into x plus 3 divided by x minus 5 whole square less than 7. Now you can cross multiply. Okay. Now x minus 5 into x plus 3 less than 7 into x minus 5 whole square. Now you can multiply this, you can expand this, take all the terms to one side, okay, and solve the equation. But generally this is how you need to check for the two rules in solving the inequalities. Now let's go through the third rule. Okay, if a and b belongs to real numbers and x is a variable which also belongs to real numbers, okay, and if I write something like this, what does this mean is x lies between a and b. If a is 5, let's say, and b is 10, then x is a variable which is changing. It can be 6, 7, 8, 9. So it is in between. X lies between a and b. Or else, whenever you see something like this, a is less than x less than b, you can simply write that in this notation. Okay. Similarly, if I write a comma b, then I can simply write x belongs to R, a less than or equal to x less than or equal to b. What does this brackets mean is including a, including b. That's why you have kept a less than or equal to x less than or equal to b. Here, this open brackets mean excluding, and this closed brackets mean including. Okay. Similarly, what does this mean? Including a and excluding b. Therefore, including a and excluding b. Alright. And what about this one? Including b and excluding a. Simple. Now, similarly, what does this mean? This means x is greater than or equal to a. If this is something like this, x belongs to R, x is greater than a. Alright. So this is general notation that you need to learn. This is the third important concept or rule that you need to learn here. Final concept of understanding is tackling the model 2 problems. So this is a problem. They'll give you the f, they'll give you the g, and they'll ask you a bunch of different things. This is called as algebra of real valued functions. They'll ask different algebraic operations between two real valued functions. So here is a concept. If f and g are real valued functions and a and b are domains of f and g, if a and b are domains of f and g, then a intersection b does not belong to null set. A intersection b does not belong to null set. So always remember, f and g are two real valued functions and a and b are domains of f and g. Now these are the functions, algebraic functions, simple functions. There is straightforward. F of plus or minus g of x is equal to f of x plus g of x. F g of x is f of x into g of x. Here is c is a constant. F plus c of x is f of x plus c. And c is a constant and multiply with the function, you get c into f of x. For the division also, this is simple, straightforward. For modulus, it is again straightforward. For power, it is straightforward. For the root also, it is straightforward. But the most important thing to remember here is the domain of any of this algebraic expression, any of these algebraic operations. The domain of any of these algebraic operations is equal to domain of f intersection domain of g, domain of f intersection domain of g. Just you need to remember this one, and as we solve some problems you will be able to understand how to do this.